objective, and that's how the this calculator was developed. So before I'll move, just I'll show an example that how the calculator is working. So if you see, there's a map. If I click on the map, so what I have to do, let's say there's a building that I have to use for installing solar, and as an end user, I know this is my building. So what I do, I'll mark the outer outline. So first, the coordinate is marked. Second, build the outline to mark as a work area. And these green dots are the shadow objects. If there's any shadow object, I have to just mark and put the height, so that the software will calculate what is the workable area and what is the shadow-free area. So as an end user, it doesn't have to calculate the shadow-free area. Now the system is automatically calculating the shadow-free area, and can just see, okay, this is the final shadow area. Based on the area only, he can see this is the PV he can install. But this is not the end, because now he is also looking for the DG replacement solution. This data will only give him the total potential of PV based on area. Now, so by entering those details, he will get the rooftop area. Now, from the electricity bill, he has to enter the average monthly bill and consumption, which any business owner will have handy, because everyone pays the electricity bill. What is the average diesel usage? If he has a battery inverter system, then he has to mention. What is the average demand? This is optional. Is there any critical load? Then he has to enter. What is the maximum demand? This is also provided in the electricity bill. Battery system voltage, if he needs a battery system, then. So by entering these basic details and selecting the business model, what he exactly is looking for, and it is for the full load or critical load. So if he clicks on the first business model, and so the system will, within a second, it will show what will be the recommended battery storage capacity, PV capacity, how much rooftop area can be used to complete the solarization. There are the financial recommendations. So all these data will help. So he is getting a technical as well as a financial. So similarly for the different business models. So first is the replacing entirely, then integrating. So that's how he will get the informations, and it will solve him to make an informed decision. Then he can contact the suppliers, and then he can, and an end user who can find out what will be the exact sizing that he will get. But as a layman, he will get informed information. And so this is the final objective of the calculator that we had, and that's how I complete my presentation. So I think there are other panelists as well who will be discussing more on the different aspects of the storage and the international exposures that the system will have. Thank you, Ranjan.
Thank you, Pulkit, for that wonderful presentation, and I'm sure we are going to have much more discussion on this findings and aspects later in the panel discussion. So before I call upon the next presenter, I would like to have some polls to get their opinion of all the attendees joining today. So just to know which power sector you belong to, currently joining this sector. So kindly select which 2 more seconds, some more seconds, then I will close the phone. So most of you are from the developer, IPP, EPC, and the consultant background, and also we do have a good number of manufacturers. So welcome all, and thank you for joining our today's webinar session. Can we have the next poll, please? So, do you have a diesel genset either in your this apartment, are you dependent in some way on a diesel genset? So this will be interesting to see what current composition in the audience are currently dependent on a diesel genset. So 5 more seconds for the voting line to remain open. And now let us look at the results. So yeah, 62% of you are dependent on the genset. 20% are still able to manage without that. So quite a big number who are still dependent on a diesel genset. Let's move on to the next poll. So, do you think solar plus storage is economical than diesel genset? There are many options for you to select from. If you think they can already be economical, or it will take some time, or you think it can never be economical, or you think that it's more risky than that, which is why I think it's economical. So please do let us know your viewpoint on this as per your understanding of this whole situation. So a few more seconds, and let us now check out the results of this poll. So most of you say that solar plus storage is already economical, which is a great news to hear from you all, and some of you say that it. So the one thing that no one says that solar and storage can never be economical. That's a good to know from you all that you feel strongly in this, and some of you still believe that more R&D will be required. This is a very good response, a very encouraging response in the solar plus storage direction. Can we have the next poll, please? And the major thing is the reliability. So do you think that in terms of reliable power backup, the solar plus storage can completely replace, or it can partially replace, or it can never replace? And do you think you cannot answer because of the more in the market? So because as we know that we are currently dependent more on a battery, on a diesel genset for maybe for running heavy loads. So what do you think if it can fully replace? So voting lines are closed now, and you can see the results. So there's a tie between it can completely replace and it can partially replace. So a number of you feel that, which means that at least there is going to be a big change if solar plus storage can actually help to partially or fully replace the diesel genset. And some of you still believe that it can never replace. So, and can we have the last poll, please? So the last poll is about what do you think is the key challenge which will hamper replacing the storage? Is it the economics, or you think, or you're afraid of a longer power cuts, or you're worried about the load of the heavy loads, or any other reason which you think is not mentioned here? So the voting lines would be open for 5 more seconds. So please vote. And let us now check out the results. So all of the main economics is the key challenge, and apart from that, the heavy load is a key challenge for diesel genset to be replaced by PV plus storage. And some of you should believe that it can never be solution for a longer power cuts. So it's good to know all your opinions, and we will further take this up in our panel discussion. So thank you all for participating in today's polls, and now I will call upon our next presenter, Dr. Troster, whom you already know from the past 2 days. But I would like to also request him to briefly introduce himself, and I would ask him to take over the screen. Dr. Toaster, it's over to you now.
Okay. Thank you, Kanjan, for this very nice introduction. My name is Eckhard Tröster. I'm with Energy Nautics, CEO of Energy Nautics. We are specialized on grid integration of renewable energies. I talk about international experience of diesel gensets for solar and storage. And what we have done is actually quite some work on island systems where there are typically diesel gensets used, and where now solar and storage is coming in. And I would like to talk about this, especially about technology used, about techno-economic aspects, and then also operational. It will be a very short presentation. I think we have some more speakers in the line. So, first of all, we have to see what is the actual situation we are facing. We see that different situations are actually then lead to different solutions. In our case one, we have a very modern diesel and control system. Typically, this is very efficient. There's little emissions with it. Fast run rates are possible, short startup times, and also low minimum stable output. Like below 30%, even more, much more than that. I've seen gensets which are able to go down to 5%. And for this, we typically see that PV can be very nicely combined with diesel. They can work very well together, and very often actually investment, at least in large batteries, is often not worth it. Typically, small batteries combination used. I will come to this a little later. On the other hand, we have the case two, the ancient generators, which is quite common. Where we have very high emissions typically. It's a manual control, often with very slow ramp rates, long startup times, and also the minimum stable output is typically quite high, above 50%, some say 70%, 80% even. So there we do not see any chance really to add PV without actually adding also a battery. And what's nice about this also is that if we are adding a battery, then we can also, this would also allow for actually moving the old diesel out of the way. And the magic word about that is grid forming inverters. So to continue on this diesel, it's often the question, what is actually the capability of the diesel? That's something you need to find out in order to then set the right settings from a dynamic point of view of the battery to be added, for example. And depending on who you actually ask, you get very different answers. So first of all, if you ask the operator, then it typically tells us fast ramping is not possible. On the other hand, if you ask the crew of the diesel, they say, well, no problem, watch this. And you can actually see on the left-hand side that there's a very low minimum value up to 35 kW of 350 k or 650 kV diesel. So that's 5% approximately. And within 10 seconds, able to ramp 250 kW. So that's possible. If you ask the manufacturer, typically says, of course you can, but at your own risk, we do not take any liability for that. And the economist typically says ramping is expensive, please avoid that. So this needs to be taken into account. So technical, typically it's possible, but from an economic point of view, nobody really likes it. No, let's have a look at an example. An island here with 52 and load between 50 to 100 kilowatts, some extreme peaks, 200 kilowatt. There's a 250 kilowatt genset there. The fuel price is 70 US cent per liter diesel. You can see different load profiles, daily load profiles. And if we go into that, we can first of all see that it is operating at a very low load. So this is the nominal load, basically it's operating at a very low load and also pretty poor efficiency. You can see here the efficiency. So if you calculate that, we come up with an LCOE of 0.438 US dollars, 43 dollar cents. So we add the PV system to that, the 65 kilowatt PV system, we do achieve 60% instantaneous penetration of the PV, but still 25% are curtailed. You can see that here, these gray zones basically. But we also identified the stability problems because the diesel is quite fast. And by doing this, we get 9% reduction in generation costs down to 39 US dollar cents and 15% annual PV contribution. That's not too much. So we believe if we add more, it is possible. That's what we did. 360 kW PV with a 1 megawatt hour lithium ion battery. Still, there's a 25% curtailment. You can see this again here, but we can further reduce the generation cost by 25%, or in total 25%, and have a 75% annual PV contribution. So this example shows it very nicely, especially during the day, that you can completely replace the diesel and therefore have a really high share of PV and is even economically interesting. And therefore, I think, as I said, what do we see? It's here the yellow line is the load characteristic. We are now operating rather in the area of 2 megawatts here. This is the purple is the diesel, and then there's the morning, the sun comes up, so that's operational. As soon as the sun comes up, then the diesel ramps down basically to its minimal load. Okay, it's not having the 5%, but rather in the range of 20% approximately. And there is also a small battery added, which is taking some peaks, and then there's some curtailment happening up here. The battery tries to compensate. It is full at a certain stage, and it goes down, basically cannot operate further. We have a certain amount of curtailment during the day, and then at the end, if the PV is not sufficient anymore, the diesel ramps up again, and we have some get some from the battery. So this is a typical operation of combination of diesel with a nominal or minimum load operation combined with a large PV system and a small battery. What happens if we have an overcast situation, so clouds passing by? The situation looks a bit different. So the solar is basically very peaky. And for this, it's quite good to have a battery now included because it can actually compensate for these large PV fluctuations, the green line you can see here, and therefore extend the lifetime of the diesel. So it's always to recommend to have at least a small battery together with these kind of systems. And finally, operation without diesel is possible. It has been shown here in this measurements. You can see it here where there has been a larger battery now included, a larger PV system now included. And what we can see here, the diesel is ramped down, it's going to a certain minimal, and then it's switching off as soon as the battery has a certain amount of storage then inside, and it continues to store it, continues to operate from here onwards during the day, purely on PV and battery, and then at the end, the diesel is then switched on again, basically, and the battery is charged, and so it's taking over, diesel is taking over. So operation without diesel is possible. Technically, it has been shown in this and many other examples, and the magic word about it is grid forming. Thank you very much.